Okay, so our second video for this week is on sequences. A sequence is a list of numbers in a specific order. Each element in the sequence is a term. In a sequence, each term has a position number. So looking at my sequence, these dots tell me it continues on. And notice that that 2 is the first term. I have the rest of the numbers, and then notice that 17 would be the sixth term. Everything in between, second, third, fourth, fifth, sixth. It's not just first and sixth, it's everything in between. Okay, let's go ahead and look at the first example. It talks about go-karting. For go-karting, it's a $7 license and then $2 per lap. It asks you to fill in, notice my purple numbers. I had already done this, I'm sorry. But I went ahead, position number, and I filled in the blank. So 1, 2, what comes after 2 will be 3, 4, then 5, 6, and then 7. And then it says your F of N, which we also know is our Y value, will be the total cost. So for one lap, it's $7 for the license plus $2 for the lap, which would give me $9. And then they said, okay, what about 4 laps? Well, I'm adding $2 for every lap to the previous number. So from 13, I'm adding 2 to get the 15. Add 2 to get the 17. 17 plus 2 is 19. 19 plus 2 is 21. 21 plus 2 is 23. And then it says to describe the domain of the function. In this case, because we're looking at our domain, which is our x is our position number. What do you notice about those position numbers? They're all positive. They start at 1 and they're all whole. 1, 2, 3. So in this case, our domain is whole numbers greater than 0. Why is it not 0? In this case, I can't have a 0 position, so it will never be at 0. Okay, let's look at the next one. It says sequences and functions. Each term in a sequence is associated with a position number. Since each position number is associated with exactly one term, sequences can be written as functions. Keeping in mind, to be a function, for every domain has to be exactly one range. That's what makes it a function. What is the domain of a sequence? And the domain of a sequence is the position number What is the range of a sequence? It's going to be the set of terms. Do sequences represent continuous or discrete functions? In this case, they're going to be discrete because we're looking at 1, 2, 3, 4. So they're whole numbers and they're integers. Okay. An explicit rule for a sequence defines the nth term as a function of n. Explicit rules can be used to find any specific term without finding any of the previous terms. In example 1, a sequence is defined by the explicit rule f of n equals n squared plus 1. Assume the domain of the function is the set of numbers greater than 0. I should have wrote that. Find the first 4 terms of the sequence. So in this case, my first term will be 1. So when I plug in 1, 1 squared plus 1 gives me 2. Then my second term, I'm plugging in 2. 2 squared plus 1. 2 squared is 4. 4 plus 1 is 5. Then I'm plugging in 3. 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. And then I'm plugging in 4. 4 squared plus 1. 4 squared is 16. 16 plus 1 is 17. Okay, now they're asking for the 20th term. Go ahead and pause your video and try to find your 20th term now. Okay, so if I'm asked to find the 20th term, what am I plugging in? You're right, I'm plugging in 20. So 20 squared plus 1. 20 squared is 400. 400 plus 1 is 401. Okay, let's look at example 2. It says a sequence is defined by the explicit rule f of n equals 3n minus 2. Assume the domain of the function is the set of whole numbers greater than 0. Didn't write that there either. Okay, in A, you're asked to find the 6th term of the sequence defined by this rule. So, go ahead and pause the video and try that now. Okay, so f of 6 equals 3 times 6 minus 2. 3 times 6 is 18. 18 minus 2 is 16. So in this case, the 6th term of the sequence would give me 16. Okay, B is a little bit different. It's not asking me to find the 6th, 8th, 9th, 10th term. It's saying which term is 121. So I'm going to go ahead and set my f of n to 121 because that's what we're trying to find. Or that's what we know. We want to know the term number. And we have 3n minus 2. Now I know from solving equations that I have to get rid of my 2 first. It's being subtracted, so I'm going to add it. And then I'm going to divide by 3. So 121 is the 41st term. Well, that was a lot easier than counting out the first 40 terms. Okay. My pages are out of order. Sorry about that. In the recursive rule, the nth term by relating it to one or more previous terms. A recursive rule cannot be used to find a specific term directly. To find a specific term, you need to use the previous term. So notice that in this formula, the f times n minus 1 represents the previous term. So we're given f of 1 equals 4, which means my first term is 4. We're given f of n equals f times the quantity n minus 1, which again, this means the previous term, plus 10, where n is greater than 1. So in my chart, my first term is 4 because it gave it to me in the question. And then I was asked to find the second term. And then I need my previous term, which was 4, that's where that came from, plus 10, because that came from the formula, and 4 plus 10 is 14. So then to find the third term, I have 14 plus 10, and I get 24. I take the 24, add 10 to it, to get my fourth term of 34. Okay. In example 2, we're given f of 1 equals 3, so that's my first term. And I'm told that we're taking the previous term and adding 2 to it. And we're asked to find the first 4 terms. So 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. Okay, I want you to go ahead and try number 3. Go ahead and pause the video and do that now. Okay, we were given our first term of 37, and then we were told that we are subtracting 3 to get to the next term, and we were asked to find the first 8 terms of the sequence. So 37 minus 3 is 34. 34 minus 3 is 31. 31 minus 3 is 28. 28 minus 3 is 25. 25 minus 3 is 22. 22 minus 3 is 19. 19 minus 3 is 16. Our first 8 terms. Okay, suppose we want to find the 50th term of a sequence. Would you rather use the recursive rule or an explicit rule? Okay, go ahead and pause the video and answer that now. Okay, I personally would use the explicit rule. Why? Because I can plug in n equals 50. If I was to use the recursive rule, I would have to find all 49 terms in order to get to the 50th. So now that you have a nice little lesson about sequences, go ahead and attempt the assignment. And if you have any questions, you could attend a live session or you can make a phone appointment with me. Hope to talk to you soon.